I'm not quite sure how to follow David's introduction. Maybe with a question for you. The first thing is, how do you know you have a pilot at your conference? Don't worry, they will tell you. My name's James Taylor. I am a pilot, and I'm an aviation accident investigator and a human factors trainer. And I feel in quite a safe space here because I'm going to confess something to you. I'm a bit of a plane spotter. And there are other spotters here, and I'm looking forward to broadening my horizons into chairs later on. I'm going to talk to you about human factors in broadcast engineering. So we are going to do some audience participation. I have a couple of questions for you coming up. Now, I think all the presentations, brilliant presentations so far today, but for me, they're all about external tech. So the questions I have for you is, how good is your internal tech, and is there any way that it can be improved? And by internal tech, I mean your cognitive ability to make decisions in your high-pressure working environments. So, I'd just like to warn you, because we are going to jump from talking about decision-making. You're all going to become aviation accident investigators, and I'll deploy you to an accident site shortly. And then we'll come back and we'll do a case study of how the news broadcasting technology team have used human factors to modify their approach to managing complex failures. I do hope you won't feel the mental turbulence as we make those leaps. But if you'd be so kind, please fasten your seatbelts. So who has made a good decision? That's a concern. Who has made any decision? Let's start there. Brilliant. Thank you very much. Was it a good decision?
Yes.
Excellent. Did you know it was going to be good before you made it?
Yeah, I decided to come here today, and I knew it would be good because I've been before.
Congratulations, sir. Brilliant. So that effectively was pattern matching. You'd done it before, so you knew it was going to be good if you came again today. And I feel under more pressure now not to disappoint you with this. So that's one of the key ways we can make decisions. We match patterns. Other ways we can say sometimes is it feels right. And that's intuition. And very often we'll just use that as a blanket explanation of how we make decisions, even when we don't really know why. Now, the latest research says that the human brain is a prediction machine. So we take raw data from the outside environment, but we combine it with an expectation of what we think is going to happen, and that then dictates our output. So that expectation is made up through our experience or our technical learning, but it's not a foolproof system. We make approximately 35,000 remotely conscious decisions per day. 3,000 of them are on food, and I appreciate we are getting towards lunchtime. But very often we stumble through that process without being present, without knowing which methods we use or where the pitfalls lie. So this is a good time to define what human factors is. So human factors is the impact of our psychology, our physiology, and our anthropology on our decision making. And by understanding that impact, we can then improve it, particularly in time-critical situations. Now, I am going to deploy you to an accident site very shortly, but before we do so, there are a couple of key concepts that we need to examine just to help us understand how accidents happen and how we can learn from them. Professor James Reason. Anybody heard of Professor James Reason? So he is fantastic. He is the father of modern human factors training, was unfortunately passed away earlier this year, but was a psychologist at Manchester University, and he developed something called the Swiss cheese model. And that moved the emphasis of mistakes and failures from the individual onto the entire system. So as you can see on the wrong one, there we go. See, it's always a worry when a pilot presses the wrong button. It doesn't happen, I promise you. I promise you it doesn't. So here we go. So there we go, lasers. You see, lasers and flying are really bad. That's why we don't use them. So we have events on the left-hand side. These pass through your layers of defense, which are the layers of the Swiss cheese. In those layers, they have holes in them. Now, these are latent holes, but potentially procedure design, insufficient training, or just being human. So being tired, hungry, I know, or stressed. And they only result in an incident when the holes line up. And the objective of human factors training is to reduce the size and number of those holes. And we're going to bear that in mind when we look at the accidents later on. I'm feeling good, I found the right button. So the second concept is that of the just culture. Anybody heard of the just culture? Brilliant, thank you. So the just culture is an organizational environment where employees feel able and empowered to report safety concerns and even their own mistakes without the fear of punishment, just purely to learn and improve the organization, but where malicious acts and gross negligence aren't tolerated. The key thing here is a balance. It's a balance between accountability and learning, and human factors can only succeed if it is used within an environment that adopts the just culture. So before I deploy you, I have to ask the question, has anybody been involved in any aviation accident or incident at all? Have you? We're going to talk about something that's quite historical, and I don't want to upset anybody. Are you happy to stay? Perfect, that's great. Has anyone got a fear of flying? Brilliant. Well, come and see me later on. We'll sort that out later. Okay. So now I'm going to deploy you to the snowy outskirts of Portland just before New Year, 1978. United 173 was a DC-8 operating from Chicago to Portland. In the latter stages of the approach, the captain lowered the undercarriage, and it didn't come down cleanly. Pilots really liked 3 green lights in the flight deck. They only had 2. There was a failure on the right-hand main landing gear. So Captain, very sensible, decided to break off the approach and sort the problem out. So he circled, stayed at 5,000 feet, and told air traffic control they had a problem. At that point, they had 60 minutes of fuel remaining. And that was required, that was the minimum fuel required under the regulations, but it was calculated with the aircraft in a clean configuration. That basically means gear and flaps up, nice smooth wings. The captain elected to leave the gear down at this point in time because he didn't want to cause further damage by raising it back in. After 23 minutes, they performed their checklist, sent the first officer down the back, because on the DC-8, very clever, we don't have them anymore, they had mechanical pop-up indicators on the wings. So he could physically look out the window and see whether the gear was down and locked. And this he did. He had a torch, managed to see it, saw the indicator was down and locked, and went back to the flight deck. After 32 minutes, ATC were asking him what the guys were playing at. Are they going to come back? And the captain then gave him a landing time, which was, again, a little bit further on. He didn't want to cause the passengers too much worry or concern, and he'd asked them to brief the cabin crew to tell the passengers that they might have to evacuate if the gear collapsed. He had no guarantees that was going to happen, just belts and braces. But equally, he didn't tell the cabin crew how long they should take over that process. 38 minutes, the captain asked the flight engineer for a landing weight in 15 minutes' time. He uses that to calculate his landing speeds, and at this point, this was the first time in the entire event, the flight engineer made a comment about how much fuel they had. He said it was going to run them very low on fuel. So just to understand what happened in the last stages of flight, I'm going to play you a portion of the ATC transcript and cockpit voice recorder.
United 173 is going to turn toward the airport and come on in. Okay, now you want to do it on a visual? Is that what you want? Yeah. Okay, United 173 Heavy, turn left heading 360 and verify you do have the airport inside. We do have the airport inside, 163 Heavy. 173 Heavy. 173 Heavy is cleared visual approach, runway 28 left. Cleared visual, 28 left. How far you show us from the field? I'd call it 18 flying miles. All right. What's our distance now? 12 flying miles. United 173 Heavy, Mayday, Mayday. The engines are flaming out. We're going down. We're not going to be able to make the airport. United 173 Heavy, Roger.
So that's quite poignant when you hear the change in tone of that last broadcast. Slightly concerning that air traffic control's response was, Roger, but all 4 engines flamed out between 54 and 61 minutes after the initial event, and the aircraft came down, event plus 63 minutes, in a wooded suburb of Portland. But why? It did run out of fuel, absolutely. I'm thinking more from a human perspective. So why did they get to the point where they ran out of fuel? They didn't, albeit actually the engines flamed out broadly when they would, so between 54 and 61, so it was only a small variation. What about how the captain managed the event? Fantastic. And probably a lack of prioritization. So the findings from the accident report were this. So a preoccupation with dealing with the landing gear fault at the expense of managing the flight. And we call this attention tunneling. Anybody suffered from attention tunneling? Yeah. Fantastic. It's one of those things. So attention tunneling is one of maybe a couple of hundred human biases. So these biases are cognitive shortcuts or heuristics that we use to reduce the load on when we make decisions. But unfortunately, errors creep in and we're not very good at spotting it. This was the first accident where human factors training was mandated for pilots and cabin crew. There were 181 passengers on board and 8 crew, 8 passengers, 1 cabin crew member, and unfortunately the flight engineer did not survive. What's the essence of human factors? Can we distill this down into the purest sense? Is anybody familiar with this particular aeroplane? Yep. Fantastic. 2 months later, after this photograph, it was this. 27th of March, 1977 at Tenerife, 2 jumbos collided on the active runway, 1 taking off, 1 taxiing. This is my personal story of how close I came to my Tenerife. Anybody know where this is? I didn't expect you to, that's fine. Los Angeles. So, Los Angeles Airport, the black lines up here, they're the 4 main runways. The grey lines, they're the taxiways. When the wind is blowing out of the west, which it was that day, we'll land to the west. And in Los Angeles, predominantly, they use the outer runways for landing and the inner runways for taking off. When we go into Los Angeles, normally 25 left is the landing runway for us. We will set that up in the aircraft actually before we leave our departure point. But generally, we'll ensure everything's correct about an hour out from landing because we start our descent, 40 minutes to go. So we'll spend those 20 minutes briefing about how we're going to fly the approach and landing. American Air Traffic Control, wonderful people, very talented at air traffic control. They're just not very good at understanding how pilots fly aeroplanes. So on this particular day, they very kindly swapped the landing runway on us 4 times. So we went from 25 left to 24 right, back to 25 left, and back to 24 right. It takes about 10 minutes to reprogram the rocks and do a mini rebrief for that runway. So as you can see, with only 40 minutes before landing, as well as flying the aeroplane, there's quite a lot going on that day. This was the bit I missed. So in my last brief for the landing runway, this little grey line here is a central taxiway, in between the 2 runways. My mental model was that when we vacated the runway, we could stop on this parallel taxiway, this parallel strip of concrete. When we eventually landed on 24 right and vacated the runway at Yankee, can you see what the problem is? Exactly. So I was incredibly lucky that day. I had 2 fantastic first officers and 45 years of aviation human factors training to help me. They both shouted stop in stereo. We brought the aircraft to a halt without spilling any gin and tonics. They weren't in the flight deck, by the way. And everything worked out absolutely fine. Now, I was incredibly lucky also that day in that there wasn't an aircraft taking off on 24 left. But if I hadn't have been present enough within that decision-making process, if I hadn't have listened to my first officers, or I hadn't created the environment that they were able to speak up and tell me, my question is, would they have said anything to the next captain, and would his slice of Emmentaler have been so kind to him? Every human factors event has a legacy. So the question is, can we take this stuff and distill it down and apply it to broadcast engineering? This is exactly what we did. So we went to the team at News Broadcasting Technology, and we tried to define exactly what they wanted human factors to do for them. And that came down to managing their event space, as we coined the term, the failure space, so the environment that the failures occurred in. These were the priorities we gave them. You can read them. Obviously, minimizing downtime is utterly important and the prime objective, but also communicating to stakeholders and collecting the data. How did we do this? Embedded with the team, it's very simple. We generated a fault checklist. So this is a checklist that doesn't manage technical parts of the fault, it manages that failure space, that environment. The idea is it's designed to minimize the risk of some of the human biases that we've spoken about, our decision-making errors, but at the same time, not to constrain the engineers so they can still use their unique knowledge. We also embedded that with some detailed human factors training, so concepts to provide context to it. Anybody heard of Daniel Kahneman? So he developed decision hygiene techniques, which minimize the risk of noise within your decision making. So what you need to do with that is when you start dealing with a fault, say, I'm dealing with a fault. Because the worst thing is if you have 2 or 3 engineers tackling the same fault but without talking to each other. You then need to separate your information gathering from your decision making because it avoids you jumping to incorrect conclusions. And it also gives you a key indication of how long you should spend before stepping back, taking a review, or asking for help. And this minimizes your risk of attention tunneling. When we were testing this, we found that when we were dealing with very complex faults that involved multiple organizations that weren't human factors aware, there was a little bit of a tendency to say, nothing to do with me, it's over there, it's not us. And it's completely natural because it wasn't that desire necessarily to be open, it's an unintended misdirection. So what we did was designed a simple framework where they could ask key questions in the shortest period of time to get the information they need to target where that fault may be. And finally, we developed a process review technique based on the APGAR score. Does anybody know what the APGAR score is? No. Does anybody have children? Oh, fantastic. Yeah, there we go.
Invented by a woman.
It was. So Virginia Apgar, a 1950s anaesthetist in America, she wanted to measure how successful the birth process had been and whether the newborns needed any specialist assistance. So APGAR stands for Appearance, Pulse, Grimace, Activity, and Respiration. So we developed the Prater scale. Anybody who knows? We needed it to be memorable. So the Prater scale was a way of measuring how good the fault process had been. And that stood for passing on information, rating the checklist, awareness, so how stressed you were, technical knowledge, was it sufficient for you to complete it on your own, expedience, how much time was wasted, and a review for the whole process. So very simple, scored out of 12. And it was used to be completely non-judgmental. So literally, once you'd finished it, and the checklists are wiped clean, so you'd use the checklist to facilitate this review, and you wipe it clean, learn from it, and then forget about it. And this was the key to embedding the concept of the just culture. So what were the critical components of success? So I think Einstein said intelligence is the measure of the ability to change. Change is incredibly hard. Pilots have a vested interest of getting this stuff right because they don't want to be the first people that arrive at the accident site. Surgeons who also do it, it's life at stake, but not their life, it's their patient's life. And thankfully in broadcast, risk to life is rare, it's just a financial risk. That having been said, it's broadly split 50-50. So you need the leadership team to adopt the just culture and embed it within the organization and use human factors language on a daily basis to encourage that. And from a team point of view, committed and curious, but they can't feel constrained by the process because it will then limit them from doing that. Some comments. These are some from the team. You're more than welcome to read them. And poor Mr. Nick Prater is in the audience, Head of Broadcast Technology. And I just want to refer to Nick. What's your feeling on the overall human factors aspects of the project?
I think, firstly, why did we put it in? Because there was a very embarrassing incident in the early stages of Times Radio where that radio station fell off the air for 40 minutes. 2 very skilled, talented engineers were working on it. They were certain they knew what the fault was and they were trying to fix that fault. Mm. It was the wrong fault. Mm. A single button press would have brought that radio station back on the air. So that was when we first started thinking about human factors. But it's become embedded far more than just dealing with an incident. So we now apply checklists to many other things that we do. An example, say we need to update the emergency audio for one of our radio stations. That has to be updated in many different places, Archiva for transmission, web streaming, disaster recovery. And it used to be, and one of my engineers earlier in this said, I fully support all this human factors stuff, but I don't need that. And there was a tendency that every time a problem came along, we would start solving it from first principles. Okay. Great if you've got experience, harder if you're new to the industry. Having that checklist for updating the emergency tape saves us mental load and lets us apply our thoughts to more complicated challenges. Brilliant. It lets us do more interesting things. I think it's a great framework for the juniors that join us that might find themselves on a weekend shift alone in charge of 8 radio stations and 2 connected TV channels and a bunch of streaming and some YouTube. When something goes wrong, we know in radio, and it can go wrong very quickly. It gives them a framework and a set of expectations. They don't have to stick to it, that's key. But if you deviate from the checklist, you need to have a good reason why.
Fantastic. Brilliant. Thank you, Nick. I really appreciate that. And I know other people might want to know from a quantitative point of view how much time is saved. It's almost impossible to dictate that because there's so many variables involved in each event. But there is an accident analysis technique where you can overlay your new procedures on historic events. And we did this, and we found that broadly the maximum that we could achieve was about a 50% time saving in dealing with technical faults. I hope that you'll want a couple of takeaways, really, what you can use next week. So there are two things, really, that I would stress. One, if you can be as present as you possibly can be in your decision-making process. And that's even something as simple as how you feel when you're caught up in the situation, how stressed you are, tired and hungry. And if you're feeling high on those thresholds, ask for help early. Do not press on, because that's when you will suffer from attention tunneling. And secondly, always separate your information gathering from your decision making, because it does avoid jumping to the wrong conclusions. One final thought for you. I think we're in awe and excited about what artificial intelligence can bring to our lives, and in particular, our working lives. However, I think it would be strange if we sat back and let that happen when we've yet to fully develop our own human intelligence, particularly in the workplace. Human factors is not a panacea, but it is a bold and positive step in that direction. And as an aside, it did help to save my life. Thank you for your attention.